Why don't boats sink? I mean, they're boats made of pure iron. If you take a floating iron boat and crumble it up into a sphere of iron, this sphere of iron will just float, will just sink straight to the bottom of the ocean. So why does the sphere of iron sink to the bottom of the ocean, and the iron boat doesn't? They have exactly the same mass, and they weigh the same. This is why. Air is much less dense than water. So the air molecules look something like this, and the water molecules look something like this. And the molecules are moving around randomly, both in the air and in the water. So now we're back to our lump of iron or steel, and let's draw the molecules. So to draw molecules in water, we'll just have to draw lots of molecules, and in the air, a little bit of molecules. So because all the molecules are moving around randomly, so these molecules in the bottom are always pushing this lump of steel up. And the air molecules are doing the same towards down. They're pushing from this side, from that side, and from all over except from here. But because the water molecules are much denser, then every certain amount of time, there's much more water molecules hitting from the bottom on this lump of steel than from the top, from the air. So the lump of steel will be pushed more up than down. So then we would expect it to float, right? But this is where our old friend gravity comes in. The force of the gravity pulling this lump of steel down is greater than the difference in the force between the air molecules pushing down and the water molecules pushing up. So because of this difference, this piece of iron should be going up, but the gravity is bigger than that force of pushing up. And that's why this lump of steel goes down. But if we would have a lump exactly the same shape, that is, let's say, a lump of wood, which is a lot less heavy, and gravity pulls it down a lot less, then the force up, because of the difference between the water and the air, will be greater than the force of gravity, and that's why wood floats. But what about our ship? Our ship weighs, and gravity pulls it exactly the same as our lump of steel. So why doesn't our ship sink? The reason is that our ship has much more surface area with the water. So let's draw the water molecules to understand that. As you can see, the air molecules in this case, between this case and this case, aren't very significant in how much they change. But the water molecules in this case, there are much more water molecules pushing up in the boat. And the reason is that there's more surface area. There's more area of the boat that is pointing down that's touching these water molecules. So in the lump of steel, there's a certain pressure of water pushing up in a certain area, and over here there's a much bigger area in any place, in any area from this big area, there's the same amount of pressure that's pushing up. So altogether, this has much more water molecules pushing up on it than the lump of steel. So even though the gravitational force pushing down is exactly the same as with the lump of steel, there's much more water molecules that push the boat up. So the boat floats. And that's why boats don't sink. Please comment, subscribe, and argue with me in the comments.